So, welcome to this final video on salt preparations, and in this video I am going to take you through how to choose your salt preparation technique. In the previous videos you looked at the techniques individually. There were 3 of them, and I hope you've learnt those now, but all the way through you're probably thinking, how do I know which of these techniques to use? And this video should take you through that. And when you're choosing the technique, the key question to ask is the salt soluble? In other words, does the salt dissolve in water, or does it not dissolve in water? And you need to be able to apply these 5 rules. Now, I'm not going to read the rules out to you, okay? Look at my new pointer, a wonderful lightsaber, together with sound effects. I'm not going to read them out to you, but I'm afraid you just have to learn them. Exam questions in recent years haven't required you to learn them, but the syllabus does state you have to be able to learn. Wrap myself in knots with that one. You have to have learned them, and you have to be able to apply them in questions. Okay, so you have to know that all sodium, potassium, and ammonium salts are soluble. Look at that, and so forth. Now, it feels a little bit dry to just have a list like that. So I actually prefer these rules represented in this kind of... Now, in actual fact, this Venn diagram is actually wrong. This is a bit of a mistake down here. That should be in the white box here. So that says insoluble. Most oxides and hydroxides. So what this shows us is which salts are soluble and which salts are insoluble, and it does it pictorially, which I much prefer to the rules. So let's nominate a substance. Let's say lead chloride. So a chloride is a type of halide because chlorine's in group 7, which is a halogen. So its ion is chloride, hence halide. So lead chloride. Let's see where we can find it. And yep, it's up here. Lead halide. So lead halides are insoluble. So lead chloride is insoluble. What about sodium sulfate? And now let's find the sulfates. Right, sulfates. Most sulfates are soluble. These 3 are insoluble. So sodium sulfate must be soluble. What about calcium nitrate? That's halides, carbonates, oxides. Here we go. All nitrates are soluble, so calcium nitrate will be soluble. So that's how to decide if substances are soluble or insoluble, and I'm afraid you just have to learn the rules. Now this slide shows you the decision-making process, if you like, when deciding which salt preparation to use. Now I must apologise, but the numbers, please ignore them. Okay, this is a worksheet taken from a resource I use in lessons, where students get all the sentences jumbled up and they have to arrange it in the right order. So the numbers don't mean anything. It should be 1, 2, 3, 4, etc. For the orders of the method. 1, 2, 3, 1, 2, 3. I think you get the picture for a method. So, as I said at the start, the first question you ask yourself is the salt soluble? And if the salt is soluble, you then, I'm afraid, have to ask a further question. Is the base soluble? And if the base is soluble, yes, you have to use this method, which we went through on the video, and that method is called the titration method. So you have to do a titration if the salt and the base are both soluble. And these are the steps of the titration, and we saw a titration in the previous video. So that would be step 5, step 6, step 7, and step 8. Now, if if you're preparing a soluble salt and the base was insoluble, you need to use this method. Now this is the method we used when we prepared copper sulfate using sulfuric acid and copper oxide. Copper oxide is an insoluble base, it's a black powder, and we added that to the sulfuric acid until no more reacted. We then filtered the excess copper oxide out, and then to the remaining solution we gently heated it to remove half the water, and then we left the remaining water to evaporate. And that was the method we used, and it doesn't actually, I don't think, have an official name. Like this method up here is called the titration method. This one doesn't have a fancy name, a sort of insoluble base method. A class a few years ago decided they were going to just give it a random name, so they named it after a gentleman called Martin. They just chose a random man's name, so it was called the Martin method. I'm not sure that referring to it as the Martin method would give you any credit in an exam. In fact, I'm 99% sure it wouldn't. But the name stuck for a whole year. Now, third method we haven't talked about is down here. So if the salt is not soluble, you choose this method. And this method was the precipitation method. I think it's the method that appears in the first video I did. So a precipitate being a solid which appears when two liquids are mixed. So you mix together two reactant solutions. Something I should say in there, which is an exam point, is that you need to stir them, then you filter them, then you wash the precipitate with distilled water, and then you allow the precipitate to dry. So those are my three techniques, but the key to choosing them is deciding if the salt is soluble. So we're going to finish with looking at a variety of salts and deciding on which method to use. So I will refer to either the titration method, the Martin method, or the precipitation method. So it might make sense that before you tackle the questions which we're about to do, you have a copy of this diagram printed out, and you have a copy of the solubility rules in front of you. Or if you know the solubility rules, that would be even better. So, here are my questions. We've got 1, 2, 3, 4, 5, 6, 7 to do. Or I could have just, I suppose, read the Roman numeral letter here. So the first one we're going to look at is potassium chloride. So have a look over your table, or your list of rules, and decide if potassium chloride, which is KCl, is soluble. And hopefully you've decided that yes, it is soluble. Now you need to decide on which reactants you're going to use to make potassium chloride. Well, you need something to provide potassium ions, and you need something to provide chloride ions. Now, the acid which will provide chloride ions is HCl. I've just realised that I'm filling this in a little bit. Not quite right. So let's delete that, and we'll decide on the method in a moment. So our reactants are HCl, and let's choose a potassium containing substance. Let's say, for example, potassium hydroxide. So as the salt is soluble, we need to decide if our base, which is KOH, is soluble or not. So in this case we have to look back at the table again. Is potassium hydroxide soluble? Yes, it is. So we're going to have to use the titration method. I'll call that titra. And I'll just fill out the rest of the equation here. KCl and H2O. Okay, next one. Barium sulfate. Have a look at your rules. Is it soluble or not? It's not. It's insoluble, so we're going to have to use the precipitation method. And we need to choose two soluble compounds to start with. In other words, two solutions to use. So we need something to supply barium. Well, let's choose a halide of barium, so barium chloride. and we need to choose a soluble substance to provide the sulfate. So have a look on the table for a soluble sulfate. Well, let's choose sodium sulfate. You could have chosen sulfuric acid or a number of other substances containing sulfates as long as it was soluble. So that produces sodium chloride, which of course we know is soluble, and barium sulfate, which would appear as our precipitate. Now, zinc sulfate. Is zinc sulfate soluble or not? We're down on to number 3. Well, zinc sulfate is soluble. And before we choose the technique for soluble ones, we need to decide on our reactants. So let's have a think. So let's have a think about what could provide the zinc and what could provide the sulfate. Well, sulfate is easily provided by sulfuric acid, which is a lovely soluble substance. And the zinc, well, that could be supplied by an oxide of zinc, ZnO, zinc oxide. So that would produce zinc sulfate and water. We need to decide if the zinc oxide is soluble or not. So go back to your table, and zinc oxide is in fact, like most oxides and hydroxides, it's insoluble. So for this method we're going to use the Martin method. And please don't use the Martin method in the exam. We're going to use the insoluble base method, but I'm going to stick to calling it Martin. Number 4, silver chloride. Let's have a look at the table. Silver chloride is insoluble, so we're going to have to use the precipitation method, and we need to choose 2 soluble substances to provide the silver and the chloride. So let's start with the chloride, nice easy one, common substance which dissolves in water containing chloride ions, could be sodium chloride. And then we need to think of a soluble silver salt, so let's choose silver nitrate, because most nitrates are soluble. That produces a silver precipitate. Very shoddy workmanship up here. No state symbols, very shoddy. And then we've got wrong icon, sodium nitrate, which is aqueous. I'm going to run out of space if I'm not careful. And I'm not going to talk through the final 3, I'm just going to fill them in. And these will be in the next video.